Hello, welcome to part 3 of the video. In this part of the video, we are going to develop the weight of each bond in this bond portfolio we need to use to hedge the liability. So as we have maturity coupon rate and yield maturity rate for each bond, we can calculate their price using this formula: settlement date, maturity date, coupon rate, yield maturity, redemption value is 100. Still has these two, and also we can calculate the duration from this. So let's we use the modified duration. So settlement date, maturity date, coupon rate, yield, maturity, and frequency. Convexity, we can use this same convexity, which is convexity. Again, we have this settlement date, maturity date, FV, future value again is 100, and coupon rate, yield maturity, and frequency. Okay, so we have all three measures for each bond. We can calculate our weight. Let's give 10% initial value to them and try to calculate what's left. So once we have this weight, we can calculate the expense for each bond. Expense actually is just simply weight times the initial value of the liability we are going to hedge. So 10%, which means 100,000. Each of them 100,000 together, or that's 6, 8 again. F4 and breakdown. If we have 10, 100,000, and the quantity is our expense to buy bonds divided by their price. So how many bonds should we use? Should we buy using this $100,000? Now we can calculate. Also, we can calculate the portfolio duration, which is the weighted average of duration and weight for some products. Duration, weight. Right. So that is our portfolio duration. So we have this portfolio convexity. Again, it's just the weighted average of individual convexity here. Some products. Weight. Right. So that is our portfolio convexity. Sum of weight is just simply a sum function. To be 100. Total expense, sum all the values here. Then we have this value. Now we want to optimize our weight. So our bond portfolio has same portfolio duration as the liability do, and we have same convexity as the liabilities do. Now we use our solver, the data solver. So we want to cite the portfolio duration to the value of liability duration by changing the weight for each bond. So we do have several constraints. So as we want to control the convexity, we set the portfolio convexity must equal to the liability convexity. Then another simple constraint is just sum of weight must be 100%. We don't have any shorts. of belonging thing. Other constraints equal to like non-negative numbers. We use this GRG nonlinear to solve. Alright, we cannot find the value. Let's solve again. Alright, so we don't have. Alright, so now I change the duration formula from modified duration to the traditional duration, and we have a result now. So that's the problem when you randomly choose portfolio. It probably have some issues like solver cannot find an feasible answer. So be sure when you build your own portfolio, choose the correct or feasible portfolios font number. Right, so now we have this weight. This is the initial weight that can match the portfolio convexity to liability convexity and portfolio duration to liability duration. Here's the initial weight we get. This is our portfolio. Next video we are going to talk about the effect of hedging using another set of portfolio, but typically the same portfolio, only we will change something. And then we were talking about rebalancing. Thank you for watching.